and welcome to Marco and Ryan's YouTube video where we will cover the basic physics concepts that go on while longboarding. Alright, the first thing we will talk about is acceleration. Acceleration is a vector quantity that measures magnitude and direction. It's the rate at which velocity of an object changes. So as you can see here in the video, I'm on my board and I'm going to push away from Marco. And my velocity at the start is at 0, but since I'm trying to get going, my velocity slowly increases, but it's increasing at a constant rate. So therefore, I have acceleration.
So the force of gravity is the force that pulls objects towards the Earth, and the closer that an object gets towards the Earth, the force of gravity will become stronger. And the further away, it can become less. It also depends on the size of the object. So as you see in our diagram here, if an object is thrown up into the air and the only force that ends up acting on it is the force of gravity, the force of gravity is 9.8 meters or newtons downwards towards the Earth, and the acceleration due to gravity is also 9.8 meters per second squared.
Now there's very little projectile motion in longboarding except for the occasional hop. Now we will explain that later. But now we're going to go over what projectile motion is. So projectile motion is an object that is launched through the air and has a parabola-like trajectory and accelerates due to gravity. Now some properties of projectile motion are that its horizontal and vertical motion are completely separate from each other. And this is because its acceleration is due to gravity. Another property is that the horizontal velocity of projectile motion is always constant. But the vertical velocity changes because it's accelerating due to gravity. As we can see here in the video, I'm on my longboard and I do a little hop. Now this is projectile motion because my motion is following a parabola-like trajectory. So I'm going up and then down, but I'm still moving forward. So that causes it to be a parabola-like trajectory.
So circular motion is an object that involves following a circular path. The velocity in circular motion is always going to be constant, but the vector quantity of the velocity is always going to be changing as it follows the circular path, which also makes the acceleration of that object go towards the center of the circular path. As you're going down the hill, your wheels are rolling and they're following a circular path, which makes them have circular motion.
Now we will talk about displacement. Displacement is a vector quantity measured in meters, and it tells how far an object is away from a given point. So for longboarding, if I started out at my house and I went all the way across my street on my board, my displacement would be the distance from the house to where I ended up. Now if I went across the street and then back to my house, my displacement would be 0. Displacement is always measured relative to a point. So as you can see here in this diagram, the distance of this object that traveled this path would be 2 plus 2 plus 2 plus 2, which is 8 meters. But the displacement of the object is 0 meters because the object is going around and then ending up at the same point. So he's not actually traveling any displacement because it's measured relative to A.
Alright, the next force that we're going to talk about that relates to longboarding is friction. So as we can see here in the diagram, we have an applied force going in one direction and the force of friction going in the other direction. So the applied force is going to be equal to the force of friction when it's in motion. So that's called kinetic friction. And when you first start off, you have static friction, which will be greater than the applied force since there's no applied force. So how friction relates to longboarding? We're going to be using kinetic friction because you're always in motion. So the force of friction is equal to mu k times Fn, and Fn is the force opposing the force of gravity, as you can see in the diagram here, and it's the force that stops you from falling through the ground. So as we can see in the video right now, I'm going to be doing a slide. So because my wheels turn sideways during the slide, it causes the wheels to stop rotating, and it causes the force of friction to stop me from going down the hill.